It's our eighth lecture for Introduction to Computing Mathematics, and in the previous lectures, we have been talking about the Boolean expressions and the Boolean logics and how to create the logic gates and how to work with them. So today we are going to proceed that learning outcome, and we will see how the arithmetic and relational operators work, and we will also see the use of truth tables and how we can deal with them, the simple calculations, and how we can employ those logical expressions into the calculations. So let's start with the arithmetic and relational operators. Arithmetic operators allows the program to perform general algebraic operations against numeric values. Whenever you want to deal with the numeric values, you can use the arithmetic operations. There are basically five operators that are working in the C hash programming languages, and there are multiple other as well. Like there are multiple programming languages that are working nowadays, and we have these basic functions or the arithmetic operations installed in almost all of them. Like the addition, subtraction, division, multiplication, and the modulus. These are the basic functions that are being performed by the basic symbols, and you can say that the functions that are being used in our programming languages. Addition one is used to perform the addition of operands, and to perform the subtraction we use the subtraction symbol, and these symbols helps us to simplify the process of all these operations in our programs. So let's see an example of a computer program in which we have two integer values. Like the integers are named as A and B, and their values are 10 and 5 significantly. So we have a variable with a name with its name result, and we have identified its data type as integer. Int is basically a data type that is already assigned to this variable, and we can only store the numeric values in integer data type. So we want to perform the operation on numbers. We are only dealing with numbers. Easily identify this data type so that we can simplify the process or the understanding of even the beginners or the people who don't have such knowledge. Then we have the integer, and we will perform different operations on this variable that we have created with integer data type called result. And we are going to perform the addition, subtraction, multiplication, division, and modulus on it. And let's see what will be the results of this operation. We have the value 10 and 5 for A and B. So the result of the first operation will be 15. The summation of two integers is, as we all know, the result will be the same. Whenever you will do this, and like write this statement as in your programming tool or any software that you are using to write your program, it will help you to understand the outputs significantly. So you can write up your program, and also you can see what will be the result of these operations. Let's see. The result of the second operation will be 5. Whenever we are going to subtract some numbers like the number A and B, then the result will be 5, because we have two integers and their result is same. And when we do multiply them, the result will be 50. And when we will do the division, its output will be 2. And whenever we do the modulus of them, the remainder will always be 0. So one should remember that the result of the operation will depend upon the data type used to store the result. If you want to store the results in the result variable in numerical values, then integer is the best data type. Otherwise, you need to see if there are some characters or some Boolean expressions. You will choose the data type as per the requirements of your data or your um, computer program in which you are working, so that you can understand which one is relevant to your needs and how you can complete your computer program with those requirements. So if the division of two integer values return a float value, and if the result is assigned to an integer variable, then the decimal part will be lost due to different data types. So because of the integer data type, we cannot store the floating point numbers. The floating point numbers are the ones which have point in them. Let's suppose we say that we have some numbers like if we divide 10 by 3, so we will be having something like 3.333 type of number in the result. And in the integer data type, we cannot store floating point numbers. So if we have such numbers, then we need to create a data type which will be in the float data type. And here when we assign the variable and a data type or a name, then we will add the float result in it rather than int result in it if we have to enter the numbers in floating points. So if we want to store all the parts of that number, otherwise it will only store the number before the point, like 3.333. It will only include the number 3 there because its integer data type allows it to add the number before the floating point. And the modulus operator is different than the other operators. It returns the value of the remainder from the division of integers. Let's say if we divide the 20 by 6, then the division operator will return an answer as 3. The quotient and the modulus operator will return 2. So the remainder of the division is basically it's something in which you need to see the number and the results that are expected. And once you know what is your number and how you are going to deal with it, then you need to find out the best data type relevant to it. Is it clear till now? Good. If anyone has any question, you can ask me. So next one is, other than the above five defined operators like the addition, subtraction, multiplication, division, and modulus, the two special operators are here that increase and decrease the variable value of a variable by one. In the numbers, when in the computer programs where we have the continuous numbers, like you want to add something from 1 to 100 and it's a continuous sequence, what you can do, you can write a program statement which will let you to increase the number by each iteration by one. And same as if you want to go from top to bottom, then you can add you can simply decrease the number from 100 by 1. So this is something which is used in the computer programs to write down the number of statements. Like if you want to write one statement multiple times, then you can use the computer program. And these operators are the most significant components of that computer programs in which you want to iterate the program multiple times. So these operators can be prefixed or suffixed with variable for operation. Like you can do plus plus one or one plus plus by adding them to your computer program, and it will add the number by each iteration. Let's suppose you have written, you want to write, let's suppose you want to write I am, just like I want to write I am Aisha 500 times. So you can simply give the constraint of 500, and once it will be at 499, till then it will add the number 1 and it will write it down again and again and again, and your number will be added. So this is the whole continuous process, and the plus plus and the minus minus are the two increment and the decrement operators. These are the most commonly used operators in the computer program. Here we have an example of a computer program. We have an integer a and b, the same one with 10 and 5 numbers assigned to them. And we want to do the increment and decrement. Once you are going to increment, what it will do is increment is equal to a plus plus. We have first made two variables, the increment and decrement, with the data type integer. And now we are going to assign the increment with increment operator. It will do a plus plus, and whenever it will run this statement, what will happen, it will add 1 point to 10 and it will show the result 11. Again, if it will, like we will call this operation again, it will again add the number 1 to the corresponding number of a, which is 11, and it will show the result 12. So this is the continuous process. Same as whenever we will do the int decrement function, it will minus out one number from the integer b value and it will show the result 4. The value of b will be decreased by 1. So this is the whole continuous process. You can call this function again and again, and you can also fix the number of times you want to repeat this statement or this function. Any relation between the two operands it is validated by using relational operators. Relational operators return Boolean values. If the relation between two operands is successfully validated, then it will return true, and if the validation fails, then false will be returned. Relational operators are mainly used in decision making or for defining conditions for loops. Whenever, just like I have told you, I want to write I am Aisha 500 times on my screen. So, what I can simply do rather than writing it down for 500 times, I will create a loop and assign the number 500 to it. It will display that phrase 500 times on my screen within a few seconds, and maybe the second is more time for this operation to be performed. So whenever you want to make some loops or you want to put some conditions into it, just like I have talked about the increment and decrement operators, you want to add some conditions for it, or you want to define the loops or any other thing that you want to do, you can use the relational operators. It will create a relation between the operands and it will validate the function. It will validate till the number 500 is achieved. If it is achieved, then it will stop the function. Otherwise, it will keep on repeating itself just like we create a loop. It will keep on repeating until the number 500 is met. Once it is met, it will terminate itself. You don't need to stop it at the number 500. I hope this thing is clear to you all. If there is any question, you can ask. Okay, then let's go to some relational operators. So here we have some of the relational operators that are offered by C hash, but there are basically all the programming languages have these functions or operations already being used in them. So the first one is the greater than operator. It checks the number, like it validates the greater than the relationship between operands. You will assign this operator to two operands and it will check which one is greater and it will display it on the screen. The other one is the less than operator. Again, it will validate two operands and it will let you know which one is the less than operator. Like it will always return to the value which is smaller. Equal to operator validates the equality of two operands. It checks and lets you know either both of them are equal to or not. Greater than or equal to is the one which validates greater than or equal to the relation between the two operands. It means that the one which is greater or equal to the number that is given. Like if you want to see the number till 500, so it will see either it is 500 or it is greater than that. If it is equal, then it is okay. Otherwise, it will say that this is not the condition that is met. Less than or equal to says that it will validate less than or equal to the relation between two operand. If it is less and it is equal, then okay. Otherwise, it will let you know to statement or see the number is not equal. The next one and the next operation is the not equal. It is denoted by this not equal to sign and it validates not an equal relationship between the two operands. Where the two operands are not equal, it will show you the results and it will let you know that these two numbers that you have added, let's suppose the 10 and 5, are not equal to each other. So here we have an example of a computer program in which we are going to use all these operations. We have again that two integers a and b with the numbers 10 and 5. We will check the validate all the functions. We will validate a is greater than b and it will let us know the results in true and false. If it is true or false, it will let you know and you can easily consider the results. So the next thing is it will add the results if either it is a is greater than b, a is less than b, a is equals to b, a is greater equal to b, a is lesser equal to b, or a is not equal to b. You will check them all. The console write line is basically a statement which helps you to write on the screen and it will display the results after it. So A is greater than B will return true because yes, it is true. A is less than B will return false because it's not true. A is equals to B will also return false because both of them are not equal. Greater equal will return true as A is greater than B and the operator is looking for a successful evaluation of any of the given condition for returning the true value. Like if it is greater or it is equal, it will see and let you know. If any one of these statements is true, it will let you know that one of them is true. So the result will ultimately be the true. As the given example returns true in both cases, the operator will return true. A is lesser equals to B will return false as A is neither less than B nor A is not equal to B will return true because it is true that A does not equal to B and there is nothing between them which is equal. So this was about the arithmetic and the relational operators. Now we are going to describe the use of truth tables. Truth tables are basically the tables that we use to make for the better understanding of our logical operations and all the other factors that we are dealing with. A truth table provides a method for mapping out the possible truth values in an expression and to determine their outcome. Once you are going to deal with truth values, okay, so let's um, go into a small question. And you people let me know what are the truth values for a truth table. It's true and false. Very good. Yes, 1 and 0 is also good. We have basically two possibilities for truth values. Either it's going to be true or false. So we can easily complete this by our truth values. So here in the truth table, we use the truth values in an expression and to determine their outcomes. The table includes a column for each variable in the expression and a row for each possible combination of truth values. So we have uh, properly made table for each possibility for the truth values and we can describe them. How do you complete a truth table? To construct the truth table, first break the argument into parts. Like you need to make the proposition for each of the statement or the argument that you have. Its negation if part of the argument and each connective. The number of the part there are is how many columns are needed. Like if you have two possible possibilities like A and B, and you want to check their table, it will be 2 into 2. And if it is then three numbers, then it will be 2 into 3. So you need to see, and after like multiplying the number with 2, the number of operands, you can simply say the number of operands, you will multiply it with 2 or 2 raised to power the number of operands that you have. It will be basically the number. Let's suppose we have three numbers, so 2 raised to power 3, which will result as 8. So you need to have 8 columns and in your table, and it will help you to create the results in it. So secondly, you will determine how many rows are needed. Since each proposition can only be either true or false, there are two choices for each proposition. Therefore, the number of rows is 2 raised to power n, where n is the number of propositions in the argument. And third, the connecting columns are filled in. Each column is based on the individual parts, the truth values. Here, a truth table is a table or a chart used to illustrate and determine the truth value of proposition and the validity of their resulting argument. For example, a basic truth table would simply be the truth value of a proposition P and its negation or opposite, which is basically not P, denoted by the symbol this. This is basically the symbol of not P. So if we have two possible values, true and false, its negation will always be the true will be the false and the false will be the true. So we have only two possible values for this truth table. So let's see the application of truth table, how we can apply the things that we have discussed into the actual practice. We have learned how to take sentences in English and translate them into logical statements using letters and the symbols for the logical connectives. we have been working with the logical operators and the logic gates, and we have seen how we can identify their working and we can make them work properly. So, if you are using the letters and symbols for the logical connectivities, then we have learned how to obtain a set of the truth values of a statement in every possible case by making a truth table. Like, it is hot today and it may rain. So it is a statement and it is in English. We can identify with the logical gates which are and or not, and we can see either it's working fine with it or not. And if it is true or false, we can make the table significantly. Now we can take these tools further to do two important things. We can prove that two different logical statements are equivalent or not equivalent to one another. We can test the validity of the structure of logical arguments, and how we can check the validity by making the truth table, and we can see the logics that we have created. Like, we have an English phrase or statement, we can simply check its validity by its truth table. So, is it clear to you all? Or if you have any question, you can ask. Okay, very well. Let's start with our next learning outcome, which is to perform simple calculations and apply logical expressions. The use and study of logic involves finding a new fact by analyzing whether some other facts together can prove to be true. Some facts or conditions, when looked at together, may prove another fact to be true or may be false. So it depends upon the logic. There are some factors that you need to see that either your logical expression is true or not. If the temperature outside is below freezing and you don't have a coat, you will feel cold. This is a true statement. If you are not sick, then you will feel well. If you can swim or ride in a boat in water, you will stay afloat. So these are the statements that are true by any means or are interrelated to each other. These are statements of fact that result from some conditions being true. So you need to see your conditions like that are basically relevant to each other. If the temperature is freezing and you don't have a coat, if you have a coat, then you will not feel cold. But if you don't have a coat, then definitely you will feel cold because it is already freezing out and you don't have a code to rescue. So this is something which is showing the relationship between the expressions, and you need to find out which statements are interrelated to each other and how you can deal with them. By taking some facts and putting them into a logical form, we can make an arithmetic operation basically that helps us to analyze them and make a conclusion. Using the examples just mentioned, let's turn them into some logical word equations. And when we are making them logical expressions or logical equations, it says that outside temperature is freezing, and here is basically an expression of logical gates. So it's a logical operation which is, and we are going to perform it here. And we are saying that I have no coat, which is equal to I feel cold. So when we know when the and is the operation between two numbers or two variables, then what we will say, if the outside temperature is freezing, like, if and operation says if both the outcomes or the inputs are true, the outcome will be true. Otherwise, if one of them is true, it will be false. Okay, so let's see if the we are going to use tick and cross for them. Let's see if the outside temperature is freezing, like it is true, and I have no coat is also true, like I don't have coat, then I will feel cold. It is, and if I'll say that it is cold, like it is freezing, but I have coat, which means this one is false. And again, if the temperature is not freezing and I have coat, what will be the result? And significantly, if the temperature is not freezing and also I have coat, then what will be the results? Okay, so anyone who would like to let me know, for AND operation, what will be the result? We know in AND operation, if both the statements are true, what will be the result? Good, Afan. And Abdullah, it's for you. If one of them is true and the other one is false, what will be the result for AND operation? Equal. In what sense you are saying it will be equal? You need to let me know either it will be true or false, because in this logical operation we have only two possible possibilities, like it will be true or false. There is no other possibility here. In AND operation, what will be the result if the okay, so if we think about it logically, you can let me know, if the outside temperature is freezing but you have coat, will you feel cold or not? Yes, it will be false because you will not feel that cold. Okay, Aspa, the next thing is for you. If the outside temperature is not freezing and you don't have coat, will you feel cold? If the outside temperature is not freezing and you don't have coat, then how will would you be feeling cold? No, yes, it's false. Yes, Afan, the last one is again for you. If the outside temperature is not freezing and you have cold, what will be the result? Very good. It will be false. Okay, so I hope the logic is clear to you all. So this is the way we do the operations with and, not, and, or in the example word equation. These are our logical operators. Every day we make decisions when we think about one or more facts. There are lots and lots of other options for the statements that you can use to make these logical operations. And sometimes it's necessary for all facts to be true in order for the conclusion to be true, like in the and operation. Sometimes it's okay if the one of the statement is true, then you can say it will be true. And when analyzing facts with or operator, only one fact need to be true for the conclusion to be true also. So this is the way we deal with all the operations. If you have any question or anything is unclear, confusing, and you want to ask something, you can ask up. Okay then. Okay, then I will see you guys in the next class. Till then, take care of yourself.